Let's talk about quicksort algorithm. Let's just assume that this input array is got n number of elements. We must select a split value. So this split value is what we call pivot. It's a number, a random number that is selected. Your split value is somewhere here. Let's just say it's the split value is, like 2. So in this array, you could have values that are kind of bigger than this. The elements in blue are all bigger than the pink one, right? So the pink one, remember, is your pivot. The green ones are values that are lower than your pivots. Let's just say these are the green ones, okay? Equal to less than, okay? The pink one, which is your pivot or splitting value. Based on the split value, doing this split or partitions, there is a partition steps here. The idea of partitioning is to split up your value such that based on the pivot that all of the higher values sits on the right side, value lower than the pivot would be on the left side. So what you end up with is something like this, an array with a pivot right in the middle. After the partition, you will have all of the higher values to the right of your pivot, and values are lower than your pivot is going to be on the right side. So this is the new array formations, and this is your new array. As you can imagine, after just one partition, right? This is the split we're talking about in the previous video. You'll have this formation. This guarantees the values are to the left, which is in green, of your pivot is our splitting values are all lower than this P. And the values to the right of your pivot or splitting value are greater than or equal to pivots. We have to continue to sort it because we need to sort every single one of these elements. We wanted to further partition this. The quick sort to the left subarray happens then, and then you have the right array. So you want to be able to subdivide this one again as well. But you have to select a brand new pivot, pivot prime, pivot double prime. These are all different. Each recursive call into quicksort would have this capability of electing a new split value. And based on the split value, the new boundary. This P does not necessarily have to be right in the middle. So this P could be all the way on this side. So it's skew. So wherever you do a partition, there is no guarantee that you're going to split your entire input array evenly. So how do we select split values, right? So we're going to talk about that. The value for the split is set to be the first. This is the pointer that we use the very first time you're doing a partition. First is 0. The array indexing starts with 0. In some other textbooks, people like to use midpoint, pick the middle element as pivot. So midpoint would be low index plus parentheses high index minus low index divided by 2, and so on and so forth. And then you find your pivot that way. Whether you pick the very first value as your split val or pivot, or the middle one as your right, it doesn't really matter. There's advantage in doing one way or the other. It depends on the nature of what you have inside the array. So let's move on. Your textbook method makes use of the very first split. This is the partition number 1. Your pivot is your first, which is 9. Using 9 as a pivot, we want to group the remaining set of elements. Any elements that is greater than 9, you want to have it slotted into the right side of your array. Anything that is lower in value than your pivot, you want to be on the left side. This is one partition. Your first and last index will then keep on moving towards convergence right in the middle, swapping of the two, eventually landing into this. What you end up with is you have a split point at index 2, index 0, index 1. At index 2, which houses your split point, basically the dividers between the larger group and the smaller group. You recurse further into it. If you look at the quicksort recursive call, it is pretty simple. First of all, you take the first and the last. This first and last is always going to be different. Initially, it's going to be 0. This is going to be n minus 1. Assume that n is the size of the array. Further down the road, as soon as you split resulted in index 2. This split point is at 2, and that separates left and right. So this is from first to split point minus 1 is the left portion, and then you have the right portion, which is at this location. Right portion is anywhere from split point plus 1. This is split point right here. The split point is right in the middle. So what happens is anything that is towards this split point, which is first, all the way to split point -1. This region is what's on the left side. Anything to the right of your split point, which is split point +1, all the way to the last one, is the stuff on the right side. The two recursions, quicksort, first, split point -1. The second one would be split point +1, last. This is your base condition, and this is your general case. So base condition, general case, so that makes quicksort a recursive call. But the most important part is actually the split. This is where the meat is. Let me undo this. This entire thing here is the meat. This is in some other textbook calls partition. This partition method and the election of your split point as well as your splitting value are the basis for quicksort algorithms. Let's move on to the next page, which shows the split operations. Your split value or your pivot is the first element. So in this case, 9. We use 9 as the pivot to regroup all of the elements. This is all done in place, okay? This is all the same array. There's no extra memories here. When we know about the very first, we want to move our first in this direction and then last in this direction, constantly looking for values that need to be swapped. What needs to be swapped is values are greater than this pivot to be on the right side. Values are lower than your pivot is going to be on the left side. You will increment your first to get to a point where the value is much greater than or equal to your pivot. And you stop right there because that element does not belong there. So what you want to do is be able to shift that element to the other side. The same thing with last, but in the opposite order. So in the last, you want to keep looking for values that are less than your pivot because that element does not belong there. As you move last from this location all the way towards this direction, 11 is greater than 9, so it stays there. 60 is greater than 9, so it stays there. But 8 does not belong there, right? So what you want to do, you want to do a swap. So you just keep doing. If you do a swap between 20 and 8, you end up with 8 being here, your 20 being here. You do not stop the operation of your first and last, doing increment on first and decrement on last until it crosses each other. Basically, at this point, you're going to have to make a decision on whether you need to continue or not. If you crosses each other, like last is already less than first, that means first and last crosses. This was your pivot before. You swap the last one with your pivot to ensure that this operation is complete. Your new pivot would have been established.